example 49, we're given h of x equals 4x times the quantity x plus 1 cubed times the quantity x minus 4 squared. And we're asked in part A to determine the leading term of h of x. Since this isn't written out in any kind of descending powers of x, we're going to need to look for what's the leading term by looking at the leading terms of each of the factors and then multiplying those together. So for example, I'm going to rewrite this as h of x equals 4x and then x plus 1 taken 3 times is x plus 1 times x plus 1 times x plus 1. X minus 4 squared is writing x minus 4 down twice, and then multiplying each of the leading terms in each of the factors together. So it's going to be 4x times x times x times x times x times x, or 4x and then 1, 2, 3, 4, 5, 6 power. 4x to the 6th would be my leading term. I don't need to multiply the entire thing out, just the leading terms of each of the factors. The end behavior, I'm going to jump over here to letter E, is determined by the leading term. Remember, if it's even degree and positive, both ends are going to be up. Right. The maximum number of zeros is equal to the degree of the polynomial. So whatever the degree of the polynomial is, that's the maximum number of x-intercepts that we can have. In this case, it's degree 6, so the degree of my polynomial is a 6th degree polynomial. The maximum number of turning points, in other words, hills and valleys, that we can have in our picture, our graph, is given by the formula the degree of the polynomial minus 1. It's always 1 less than the maximum number of zeros. So the degree of the polynomial minus 1, in this case, at most we can have 5 turning points. Let's go for the y-intercept, letter F here next. Y-intercept is let x equal 0, solve for y. So we've got h of x is y equals 4 times 0 times 0 plus 1 cubed times 0 minus 4 squared. Well, 4 times 0 is 0 times, it really doesn't matter what comes next because 0 times anything is going to be 0. So we have a y-intercept of 0, 0. The 0 multiplicity and behavior at the 0 is, we're looking at the x-intercepts now. So coming back up here, and I'm going to make a little room up here, we're going to set the function equal to 0. So 0 equals 4x times x plus 1 cubed times x minus 4 squared. Set each factor that has an x in it equal to 0, solve for x, divide both sides by 4, 0 divided by 4 is 0, x plus 1, don't worry about the cubed, that's the multiplicity, that's the number of times that answer would have shown up. X equals negative 1 is an x-intercept that showed up 3 times as an answer, and then x minus 4 equals 0. X equals 4 would have shown up twice as an answer. Now 4x, the degree on that is 1, so it would have only shown up 1 time as an answer. So putting your zeros in WebAssign especially, they're going to ask you to put those in order smallest to largest. So let's get used to doing that. One of our x-intercepts is -1. The next biggest one is 0. And then our largest is 4. The multiplicities are the powers that are associated with each of those zeros. So -1, the power was 3. On 0, the power was 1. And 4, the power was 2. Remember, the multiplicity determines the behavior at the 0. If our multiplicity is an odd number, then the behavior at that x-intercept means our graph is going to cross through that intercept. So on both of these, those multiplicities are odd. Odd means it's going to cross through. But if it's an even multiplicity, then we're going to do a touch and turn at that intercept. All right. So to sketch the graph, the first thing we want to do, and there's an order to this, plot your intercepts. So we've got one at -1, we've got one at 0, and then we've got another one at x equals 4. All right. We also had a y-intercept at 0, so that's not really going to change anything here. The next thing we want to determine is our end behavior. So to the very far left, our end is up. Now I don't know if it goes straight up or if it goes slowly up, but I know that both ends eventually are going up. All right. Once I have my end behavior, then I check out the chart here. At -1, I cross through that intercept. I don't know how low I go, but I know I need to come back up to this next x-intercept. And it says I cross through at x equals 0. So I cut through there. Now I don't know how high up I go necessarily, but eventually I got to come back down. That's why I'm making it a dashed line. And I'm going to do a touch and turn at x equals 4. So that's a rough sketch of my graph. So first, find the intercepts, plot those. Next, end behavior. And then the third is the behavior at the 0, or at your x-intercepts. Let's take a look at one more here on this page. So again, we're going to look at the leading term first. So I need to think about multiplying all of that out. -8, I have 4 of those. 2, 3, 4. And 3 of the x minus 1s. So the leading term of t of x is going to be -8 times, and then count up your x's. 1, 2, 3, 4, 5, 6, 7. You could add those powers up. -8x to the 7th. Knowing that leading term, I've got my end behavior. The left end is up, and the right end down. If you're not sure, graph y equals -8x to the 7th, and check out what your ends are doing. The degree of this polynomial is 7. Knowing that, I can answer part B and part C. Maximum number of zeros, the most x-intercepts I can have, is 7. the maximum number of turning points. The most that you can have is 7 minus 1, or 6 turning points. The y-intercept at this point, I go back to the original, I let x equal 0. 0 plus 2 to the 4th times 0 minus 1 cubed. Now this one isn't going to be 0 because this is negative 8 times this hot mess. So I'm going to type that one into my calculator just to see what I'm going to get here. So negative 8 times 0 plus 2 raised to the 4th, and then 0 minus 1 raised to the 3rd. I'm going to get 128. Or 0, 128 is my y-intercept. It's going to be way up here somewhere. Okay. My zeros are my x-intercepts. So I'm looking at my x equals, my x equals. I set each factor that has an x in it equal to 0. X plus 2 equals 0. So x equals negative 2. And then my other is x minus 1 equals 0. Okay. You don't set negative 8 equal to 0 because negative 8 is telling me that it got flipped and stretched. There's no x there to solve for. Looking at the multiplicity though, on x plus 2, the factor had a power of 4 attached. That's its multiplicity. X equals 1 came from the factor x minus 1. X minus 1 had a factor of 3 attached to it, so our multiplicity is 3. Multiplicity of negative 2 is 4, which is an even number, which means I'm going to do a touch and turn. And x equals 1 had an odd multiplicity attached to it, which means we're going to do a cross through. So drawing the graph of this, getting a rough sketch, again, plot your intercepts. We've got one x-intercept at negative 2, the other x-intercept at positive 1. Left end is up, so it does out here. Right end is down, so it does that. At negative 2, we touch the x-intercept and then we turn around and go all the way up to 128 at least. And then from 128 we've got to go back down to our other x-intercept at 1 here. And at 1 we're going to cross through that x-intercept. This would be a really tough one to see on your graphing calculator. Because of the numbers and the way that it's drawn up. You can try, but it's going to be pretty tough to see it. The best way is to make a rough sketch of it.